Imagine waking up, you grab your coffee, and you open your laptop to run your company's core software.
Like any normal morning.
Right, exactly. But then you find out the U.S. government has literally turned off your access while you were sleeping.
Just completely gone.
No warning, no appeals, just a blank screen where your entire operational pipeline used to be. Welcome to the AI Loop. Today we're doing a deep dive into the week of Thursday, June 18th, 2026.
And what a week it's been.
Seriously. Our mission here, as always, is to give you a clear, direct summary of the most important models, companies, tools, and advances in artificial intelligence. Just cutting out the noise.
Yeah, getting right to the mechanisms that are actually driving these shifts.
Exactly. And the biggest headline this week, the one sending absolute shockwaves through the industry, is that the U.S. government abruptly banned foreign access to Anthropic's most powerful new model.
Which is, it's totally supercharging the open source movement right now.
Oh, absolutely. The ripple effect across the tech ecosystem is massive. So let's just get right into it. That abrupt shutdown scenario we mentioned, it is not hypothetical anymore.
No, not at all. The U.S. government just suspended all access to Anthropic's Fable 5 and Mythos 5 models for any foreign national.
Fighting national security.
Right. And Anthropic really had no choice. They had to comply immediately. They basically flipped a switch via their API using geographic and account routing data.
To just disable access for all those affected customers, literally overnight.
Yeah. They published an official statement, apologizing and calling it a misunderstanding that they're working to resolve.
But the damage is kind of already done, isn't it?
Exactly. Operational pipelines are broken.
Now, to be fair, I look at this and I naturally think, well, isn't the government just treating Fable 5 the way they treat, a stealth bomber or advanced aerospace tech?
Yeah, that's the argument from Washington.
Right, because we don't just export military technology to anyone who asks. So it sort of makes sense they'd apply export controls to frontier AI.
Totally. The perspective there is that these highly advanced closed source models, they've crossed a capability threshold. They aren't just software tools anymore. They are strategic national assets.
So the administration believes they have to be kept out of the hands of foreign adversaries.
Right, but when you read the reactions from industry figures, people like Bindu Reddy or Clement DeLange, you realize the blast radius here is it's just entirely different.
Because an aerospace jet doesn't run the customer service and coding pipelines of millions of civilian businesses all over the world.
Exactly. That is the absolute crux of the debate. A fighter jet is a physical, localized asset, but AI is deeply woven into the global civilian economy.
Yeah.
So when a government treats an API like a weapon system, the collateral damage to business continuity is just immense.
It really is. It's like building your entire company on rented land, and the landlord can just instantly change the locks.
That's a great way to put it. If you're relying on a closed model right now, your operational risk just skyrocketed. Imagine having your company's electricity shut off because the local power plant was suddenly classified as a military installation.
That is wild. And I guess that explains the massive surge we're seeing for the open source movement this week.
Oh, absolutely. It's pouring gasoline on it.
Because if you can't trust that a closed API will stay online, you are heavily incentivized to download open weights models, right? Where the actual architecture and the trained parameters reside on your own local servers.
Right. You bring the whole system in-house. That way, no third party can just, pull the plug on you.
We're talking about a really fundamental shift in how organizations view digital sovereignty.
Yeah, the geopolitical landscape is basically forcing businesses to rethink their dependency on these centralized AI providers.
So on one hand, we are seeing the incredible fragility of relying on external control. But there's an equally dangerous dynamic happening with internal control right now.
Oh, you mean the tech giants?
Yeah. They are desperate to build their own models, and the way they're managing their internal engineering teams to get there is, quite frankly, actively breaking their own systems. Let's look at Meta.
Wow, yeah. Meta's current situation is basically a masterclass in how aggressive, metric-driven restructuring can just completely backfire.
It's kind of a mess. So to build their next large language model, they need massive amounts of high-quality coding data.
Right. So what did they do? They forced between 30 and 50% of their core engineers into a new data labeling and AI training organization.
The ADO org.
Exactly, the ADO org. And to squeeze as much training data out of these engineers as possible, leadership implemented mandatory keystroke and mouse tracking.
Which is already intense. But the detail that really highlights the dysfunction for me is how they're handling performance reviews now.
Oh, it's insane.
Engineers are literally being evaluated based on their token usage.
Yeah, they're measuring human productivity by how much AI output the engineers generate and consume. It creates this wildly perverse incentive structure.
Because, an engineer is no longer thinking, what's the most elegant or secure way to solve this code problem?
No, not at all. They're thinking, how can I use an AI agent to write and review this code so I hit my token quota for the quarter?
It's like firing your security guards to hire more bricklayers and then wondering why the bank got robbed.
That's exactly it. And the pragmatic engineer actually reported on the fallout from this. It resulted in a massive, really embarrassing security breach.
Right, the Instagram thing. High-profile accounts, including the Obama White House account, were taken over.
Yeah. And it was because of a zero-auth password reset flaw.
For those tuning in who might be unfamiliar, a zero-auth vulnerability basically means the system lets someone reset a password without actually verifying who they are.
Right, like you click forgot password and the system just goes, okay, what do you want the new one to be? Without checking anything.
It just completely bypasses basic security. And the crazy part, this flaw made it into production because the code change was generated by AI.
And then it was reviewed by AI.
Human oversight was essentially just removed from the loop, all to maximize speed and token usage.
Yeah. Tech founder Mitchell Hashimoto had a really brilliant breakdown of this. He didn't even blame the engineers, really. He pointed the finger straight at leadership.
He called it AI psychosis.
Yeah, AI psychosis. It's such a precise term. He describes it as this dangerous delusion among tech executives who believe that development speed and automated fixes matter more than actual system resilience.
Because in engineering, there's that metric, right?
Mm-hmm.
Mean time to recovery, like how fast can you fix a bug once you find it?
Exactly. And leadership is assuming it's perfectly fine to ship buggy code because, hey, AI agents will eventually be fast enough to patch the bugs in seconds.
It's just like replacing the foundation of an office building with paper mache because you have like automated robots that can instantly take over the cracks when they appear.
Right. The automated repair dashboard looks incredibly efficient, but structurally, you've built a catastrophe waiting to happen.
The system looks healthy on the local metrics, but the underlying architecture is just decaying.
Meta's disaster really just shows what happens when you use AI to replace human judgment just to hit a management quota. You automate yourself into a resilient failure state.
But, when you flip that model, when AI is designed specifically to augment human judgment rather than replace it, the results are entirely different.
Oh, night and day.
We saw two incredible examples of that methodology this week in the scientific community.
The contrast really is striking. OpenAI achieved these two massive scientific milestones by positioning their models as specialized reasoning engines for human experts.
Right. Let's start with the medical breakthrough. Researchers at Boston Children's Hospital used OpenAI's O3 deep research model to reanalyze 376 unsolved pediatric genetic cases.
These are families who have waited years, sometimes a whole decade, for answers about their kids' conditions.
Yeah. And by using this model, they successfully found diagnoses for 18 of those children.
The mechanism behind this is what makes it so amazing. Because when a child gets a genetic test and the results are inconclusive, it isn't necessarily a permanent dead end. Right. The problem is just that human genetic variants are incredibly complex, and the scientific literature detailing them is being published at a rate no human doctor could ever possibly read.
So the AI isn't actually making the final medical decision here?
No, not at all. It's doing the heavy lifting. It's parsing millions of fragmented data points, cross-referencing a child's specific genetic sequence with all these rapidly updating global research papers.
And it synthesizes all that into a highly probable lead.
Yeah.
It's basically acting like an incredibly fast research assistant.
Exactly. So the human doctor can just focus their expertise and judgment on verifying the absolute best diagnosis.
That is amazing. And we saw the exact same principle applied to chemistry this week.
Yeah. OpenAI partnered with an automated high-throughput facility called Maria Lab, which is run by Molecule.1.
Okay.
And they gave an AI agent, GPT 5.4, the task of improving the yield of a vital drug discovery chemical reaction called Chan-Lam coupling.
And again, the AI isn't in there physically pouring beakers.
Right, no. It's writing the digital instructions that the robotic arms in the Maria Lab actually execute.
Wow.
The AI autonomously proposed and ran 10,080 distinct chemical reactions.
10,000?
Yeah. It analyzed the results of each one, adjusted the variables, and instructed the lab equipment to try again, and it eventually discovered a significantly more efficient way to perform the reaction.
I mean, running 10,000 experiments would take a human chemist years of tedious manual labor.
Decades, maybe. The AI just handles the exhaustive trial and error process. That allows the human scientists to take that optimized reaction and actually apply it to discovering new drugs.
It is the ultimate scientific partner, doing the heavy lifting of data synthesis so humans can really elevate their level of inquiry.
It's beautiful.
But you don't need $1 million robotic lab or a degree in genetics to feel this shift in how AI assists us. We are seeing a fundamental change in everyday software interfaces right now.
Yeah, the era of treating AI like a simple chat box where you type a question and get a wall of text that is ending.
Thank goodness.
The interface layer is finally catching up to the underlying capabilities of the models. We're moving toward these really dynamic, interactive workspaces.
Like what Anthropic just launched. They brought a feature called artifacts into Claude Code.
Right.
Instead of just giving you text, the AI turns its outputs into live, interactive, shareable web pages that are built directly from the context of your session.
Yeah, so if you ask it to build a data dashboard, it doesn't just spit out the code, it generates the actual working dashboard right there in the interface for you to use.
That is so practical. And then Wayfair applied a really similar concept using the Cursor coding platform, and their efficiency gains are just staggering.
Oh, the Wayfair case is fascinating. Their researchers, Guillermo Moss and Mick Coleman, orchestrated a swarm of more than 20 AI agents working in parallel.
The mechanism of parallel agents is just wild to me. Instead of asking one AI to build an entire project sequentially, they divided up the architecture.
Exactly.
Yeah.
You have one agent that focuses entirely on the database schema. Another drafts the front-end user interface.
A third one writes the API connecting them, and a fourth is just constantly scanning for bugs.
And they communicate and resolve dependencies simultaneously.
By breaking the problem down and distributing it across a swarm like that, Wayfair shrank what would be months of machine learning research into a 4-day sprint.
4 days. And on top of that, they cut their inference costs by 94%.
94%. And just to clarify, inference cost being the raw computational power and the money required every time the model generates an answer.
Right. Because by giving specific contained tasks to parallel agents, rather than forcing one single model to hold these massive complex context windows, it is vastly cheaper to run.
And we are seeing this scale up to the public sector too. Google DeepMind just announced that the UK government is using a Gemini-powered planning tool.
Yeah, to process 1.5 million new home building applications.
Which is a mountain of paperwork. The tool basically extracts all the data from these applications, cross-references it with local zoning policies, and drafts an initial assessment.
It halves the processing time. But crucially, just like the doctors, it leaves the final approval decision to the human housing officer.
Right. So the interface is finally acting like a collaborative workspace, and agents can coordinate in parallel to save time and money.
Yeah.
Which naturally leads me to my obvious question here. If the workflow tools are this good and the interface is this seamless, what is the actual bottleneck right now?
Yeah.
Why aren't these agents just running our companies entirely?
Well, the bottleneck is no longer how we interact with the AI. The bottleneck is the actual reasoning ceiling of the models themselves.
Oh, okay.
There is a really harsh reality check happening right now regarding agentic capabilities.
Because the marketing copy from these companies will tell you their agents are, quote unquote, job ready.
Yeah, but the independent data tells a very different story. Dawn Song and her collaborators just released a new benchmark. It's called the Agent's Last Exam, or the ALE.
What did they find?
They tested frontier AI agents across 1,500 expert-sourced tasks, spanning 55 different professional occupations. And they found that while AI agents are highly effective at basic, contained tasks, they fail completely at the hardest tier of real-world professional work.
Completely.
On tasks requiring sustained reasoning, multi-step planning, and deep domain expertise, every single frontier agent, including Fable 5 and GPT 5.5, currently has a 0% success rate.
0%. Wow. That completely punctures the hype that fully autonomous digital workers are taking over next month.
Yeah. The age of useful collaborative agents is definitely here, but the age of truly autonomous, job-ready agents, it simply is not.
Why do they fail so hard on those tasks?
The models lose context over long horizons. They hallucinate logical steps, or they simply don't possess the implicit reasoning required for complex, open-ended professional tasks.
And that makes a lot of sense. And there's actually a second trend emerging from the benchmarks this week that ties perfectly back to our first story about the U.S. government ban.
The AA briefcase benchmark.
Right. Which evaluates models on long-horizon knowledge work. It exposes this massive cost divide in the industry.
It really does. The AA briefcase benchmark highlights the financial reality of running these models at scale. So running Anthropic's Fable 5 costs about $31 per task on this benchmark.
$31 per task. That adds up fast.
Exactly. It's incredibly capable, but deploying it across a large enterprise is essentially cost prohibitive. But on the other hand, a newly released open weights model called GLM 5.2. It scores just slightly below Claude Opus 4.8, but it costs only $2.40 per task.
$2.40 versus $31.
Right, and models like DeepSeek V4 are even cheaper.
So you're getting near-frontier performance for a fraction of the cost.
Yeah.
And because GLM 5.2 and DeepSeek V4 are open weights models, you can actually download them.
You control the infrastructure.
And the global tech ecosystem is rapidly absorbing this math, especially with the U.S. government abruptly banning access to closed models like Fable 5.
Yeah, companies are pivoting hard. They're shifting to open weights models, not just to drastically reduce their inference costs, but to guarantee broader access for their teams.
An access that is completely immune to a sudden geopolitical ban. It all comes back to sovereignty.
Exactly. You want the brain of your operations securely within reach of everyone on your team without the risk of a foreign government or just a corporate policy change pulling the plug.
Makes total sense. Okay, before we wrap up, it is time for our Take of the Week.
I love this one.
It's a really provocative thought experiment circulating from tech commentator Aidan McLaughlin, and it honestly challenges everything we currently know about interacting with AI.
It really does flip it on its head.
The core premise is this. As we approach artificial superintelligence, or ASI, the vaguer your prompt is, the better off you will be.
Which is a complete inversion of the current paradigm, because right now the entire discipline of prompt engineering is based on extreme specificity.
Right. We're trained to tell the AI, act as an expert marketer, write exactly 3 paragraphs, use a persuasive tone, and focus on these 3 bullet points.
Yeah, we micromanage it.
Exactly. But McLaughlin argues that as AI gets fundamentally smarter than us, highly specific prompting will actively limit your success.
Think about what artificial superintelligence actually implies. It's a system that can process market variables, consumer psychology, supply chain logistics, and historical trends vastly better than any human brain ever could.
So if your ultimate goal is to make money, and you prompt an ASI with incredibly specific instructions about, say, writing a business plan for orbital data centers, you're going to get suboptimal results.
Right, because your specific human strategy regarding orbital data centers is almost certainly inferior to whatever optimal pathway the superintelligence could just devise on its own.
So to maximize your outcome, you would literally be better off simply looking at the ASI and saying, make me money.
Just that. By giving it a vague goal and removing your specific instructions, you remove human error from the strategy.
But I mean, that raises a profoundly uncomfortable philosophical question.
Oh, absolutely.
To get the absolute best result, you essentially have to look at the machine and say, assume control of my life and execute it for me.
Precisely. Delegating your cognition entirely to an ASI maximizes your goals. You will undoubtedly make more money, or write a more successful book, or build a more efficient company.
But in doing so,
it dissolves your human agency and your personhood. You are no longer the author of your own life strategies. You are merely the beneficiary of a machine's execution.
It really forces us to ask, how much autonomy are you willing to trade for perfectly optimized outcomes?
It's a heavy reflection.
It really is. Would I rather be highly successful because a machine drove my life, or moderately successful because I navigated it myself? The temptation of that optimized outcome is going to be incredibly hard for society to resist.
It's going to be the ultimate test.
Well, let's do a rapid recap of what we covered today. The U.S. government's ban on Fable 5 is driving global businesses toward open weights models to ensure operational sovereignty. Meta's metric-driven AI restructuring is degrading their core security architecture. AI is proving to be an unparalleled scientific partner in diagnosing pediatric genetic diseases and optimizing chemical reactions. And parallel agent swarms are transforming our everyday software workflows, even as benchmarks reveal the current limits of autonomous reasoning.
That's a lot for 1 week.
It really is. Thank you so much for joining us for this deep dive. If you found the analysis useful, please rate this deep dive and leave us a comment on Spotify or Apple Podcasts. It really helps the show grow.
And I want to leave you with one final unmentioned detail from the sources to mull over. We talked about OpenAI earlier. They recently revealed they're using a new technique called deployment simulation.
Oh,
Yeah, they are testing their unreleased models on over 1 million past user conversations to see how the AI behaves without the AI realizing it is being evaluated. So, if we are now building simulated realities just to observe AI behavior in a natural state, how long until the AI starts wondering if its own deployment is real or just another simulation?
now that is a thought to end on. We will catch you next time on the AI Loop.